So we'll go through some of this together. See if you can go ahead and fill in number 1 on your own. And that should be, the notation there is f kind of looks like an exponent. It's not. And it's pronounced, how is it pronounced? Lucas Coletta. How do you read that?
Inverse of f of x.
Okay. F inverse of x or the inverse of f of x. I'm fine with that. I'm going to say f inverse of x or inverse of f of x. I'm actually okay with that. On number 2, f of x and the inverse of f of x are inverses because they literally, I don't know what word would you want to use here. I would say invert, but I don't know if that's too much using the word. They kind of undo the operations that the other one just did, right? I'm going to say invert because it does clarify it in the next sentence. Whatever f of x does to an input value, f inverse of x follows up by doing the opposite. And in the opposite order, as we saw the other day. So whatever order of operations the first function does, the inverse function goes backwards through all of that and does the opposite. Number 3, we kind of just discussed this on the last homework question. The domain of f of x becomes the blank of blank. What do you think, Jack? Let me fill in this one for you. The domain of f of x becomes the blank of f inverse of x. The domain of the original becomes the what of the inverse. Who can answer that? Georgia? The range. Very good. And vice versa. The range of f of x becomes the, Jack, can you do that now? Of? Yep. Very nice. In 4, if f of a equals b, aka that's the point AB, is a point that lies on the graph of f of x, I'll just tell you. Then f inverse of what equals what, aka BA, is a point that lies on the graph of the inverse. What do you think, Kate? Very good. F inverse of B equals A. You cannot see it at all up on the screen, but I think you can see it on your paper. Simply put, to summarize the concept of inverse functions as succinctly as possible, switch what, Natalie? X and Y, very good. Sorry, it does not show up on the screen. Maybe if I tilt it, it will. A little bit better. Okay, when graphed correctly, the function and the inverse of the function should appear to be what? Or in other words, mirror images of each other. What do you think that would be, Tess? Reflections. And we talked about this on Friday. I think Bella was the one that nailed it, right? Across, don't tell me again, but do you remember answering this question correctly? Thought it was. Yeah, that's all right. Across the line, oh, I should put y equals x, not x equals y. Same thing, but we're used to lines being y equals. I should have brought that up again when I illustrated the two pictures on your warm-up. Remember, on the warm-up, one looked like this, and the other one, oh God, was that what it was? Oh no. On your warm-up, the one looked like this, and the other one kind of looked like that. I should have illustrated it and shown you. That's across the line y equals x. That's the line of symmetry, because the original function and the inverse function are reflections across that. Okay? These all are things we talked about on Friday, but there's so many different vantage points to look at inverses from that I really think this kind of summarizes it for us, gives us another day to let it all sink in. In 7, if the point 27 lies on f of x, then the point what lies on f inverse? Morgan? 7a. It's okay.
7.
Very good. And if the point -4, 1 lies on the function, then the point what? Mike? Good. And then same idea, just a little bit of a different notation. If f of 8 equals -2, then what notational form would tell us kind of about the inverse point? Take a stab at it. Faye. -2, 8 is the point, but just to kind of follow this function notation, we're going to do f inverse of -2 equals 8. So maybe looking at it from this vantage point can kind of help us again with that warm-up issue that we had. When we were asked for inverse of -4, kind of understanding that if that's the x-coordinate of the inverse, then it's got to be the y-coordinate of the original. You kind of see that here. Here's the x-coordinate of the inverse. Well, that came from the y-coordinate of the original. You see that? Okay. And then the last one, Haley.
Inverse of -3.
Very good. Okay, when you're given a table of values of a function, we did this on Friday, we just flip-flop the order of all of those. We'll skip past that. We need to continue writing the inverse equation, that process that I outlined for you on Friday, where you switch the x's and the y's. So in part A, we're going to do x equals 2y plus 8, and then simply solve for y from here. So subtracting 8 from both sides leaves you with x minus 8 equals 2y. And then dividing by 2 on both sides will leave you with y equals, and I'm just going to leave it as x minus 8 divided by 2. How would you simplify that if I asked you to? Go ahead. 1/2 x minus 4. Very good. Okay, let's jump to D. D doesn't currently have a y in there. It's got f of x, but it means the same thing. Y equals -2/3 x minus 4. So I'm going to switch that. X equals -2/3 y minus 4. Just switch my x's and my y's to get started. And then solving for y, Chris, what's the first thing I do to both sides? Add 4. And here's the doozy for some people. How do I solve for y from here? Lucas.
Divide by -2/3.
Okay, but we don't usually divide by fractions in math. What's the equivalent to dividing by a fraction? Chris? Multiply by the reciprocal, exactly. That's just going to make it look a little cleaner. So, yes, you're thinking about dividing by negative 2/3, but that's multiplying by negative 3/2 to get rid of that. Now, you may or may not need to distribute. It kind of depends if it's multiple choice, if that, like what it looks like. If we did distribute, just for the sake of practicing, we'd have negative 3/2 x. And negative 3/2 times 4 is how many halves? Negative 3/2 times 4 is how many halves? Negative 12 halves, exactly. And negative 12 halves is negative 6. And here's the other piece with part D. It started off as f of x. A and C start off as y equals, so we can leave them as y equals. If it starts off as f of x, yes, we change it to a y momentarily just because it's easier to solve for that. But when we end a problem like that, we have to write f inverse of x equals. You have to stay consistent with the notation that the problem uses. So if it uses y equals notation, good, keep it a y. If it uses f of x notation, go to f inverse of x. Okay? A little bit of the graphing that I did on that warm-up quiz. Okay? Here's our initial function. If we want the inverse function, we're just going to flip-flop all these points. So 6, 1 will become 1, 6. 3, 3, when you flip that, it's going to stay 3, 3. 0, 5 is going to become 5, 0. And it's aligned with arrows on both ends, so I'm just going to connect those 3 with a straight edge. And label that f inverse of x. Any questions? Flip to the back. Okay, here's some more conceptual stuff. Again, it was mentioned on Friday, but being brand new, I think this stuff needs another day to sink in. Raise your hand if you think you can fill in the blank here. The y-intercept of f of x is the blank of the inverse function. Very good. X-intercept. You're Haley, right? Good job. So again, there is that x and y flip-flopping again. Angie, how about number 12? The x-intercept of the function is the y-intercept of the inverse. Very good. Writing the inverse function, that's more of the same that we did on the other side. More of the graphing that we did on the other side. And then I just want to go through 15. Okay, first and foremost, and this is going to be a review from Algebra 1, write the equation of the linear function shown. Now, some of you remember this, no problem. It's like second nature to you. Others may need a reminder. Who can tell me what the equation of this function would look like? And y equals mx plus b form. Olivia. Okay, can you tell everyone where you got negative 4 over 3 from? So you like picked 2 points probably, right? Maybe those two? And counted down 1, 2, 3, 4 over 1, 2, 3. Perfect. So she knows that m stands for the slope. And where did your b come from? Very good. So where it crosses the y-axis, b is the y-intercept at positive 8. So that was plus 8. Nice job. Now, it's asking us to sketch a graph of the inverse of this function on the same grid. There's 2 ways to do this. We could write our own inverse equation and then graph that line based on the equation, or we can just take these points. I'll come up with at least one more, 6, 0 there, and I can just flip-flop all of these. So 0, 8 becomes 8, 0. 3, 4 becomes 4, 3. and 6, 0 becomes 0, 6. And I did those with X's instead of dots. And then if I connect those with a straight edge, or my best estimate of a straight edge, that's what I'm looking at. Now, I want to jump down. We did B. I want to jump down to D, writing the equation of that. So I graphed it based on just flip-flopping the points. But using Olivia's method on part A for the original line, I want you to write an equation for that inverse, again, using her method. What is M, what is the slope, and what is B, the y-intercept? Take a minute to do that, and then I'll call on someone. Owen, what do you think? Anybody disagree? Sierra? He did say negative 3 over 4, didn't he? I wrote down what I think I heard him say. Chloe?
Shouldn't the BB be 6?
Yeah, Owen, the y-intercept of our new line is not 8. Right? You see that now? It's 6. Did you do it by looking at the graph, Owen? Okay. You can't just look at an equation usually and just know what the inverse is going to look like. You can write the inverse from the picture, which is what I asked you to do. Or you can write the inverse from that equation. It's just not going to be as simple as looking at it. It's going to be that process of switching the x and the y's and solving for y. So if I subtract 8, watch how this pans out. I get x minus 8 equals negative 4/3 y, and I'm going to multiply by the reciprocal, and I get negative 3/4 x plus 24/4. And guess what? Plus 24/4 is plus 6. So it certainly can be done both ways, either from the graph or from the equation. But if you're doing it from the equation, please don't ever think it's just as simple as just looking at it and just knowing what the opposite function is. You're not going to get that that's the opposite operations just by looking at it. Okay? Your homework is just to finish a sheet, so not a whole lot. Just anything that we skip, just go ahead and finish. The answers are not on there, so I'll just travel around the room tomorrow and call on people to share their answer, and we'll talk about any discrepancies.